Hello, my amazing friends. Welcome back in a new science lesson and a new chapter and new day. I am Mr. Muhammad Kamara, science teacher, and today we will talk about how are minerals classified. It's chapter 6, lesson 1. What we're going to learn today, our lesson objective for this lesson, we will know how to classify minerals. Wow, this picture sounds like we are going to eating minerals. Do we really eating minerals? Let's figure out. Mineral crystal. First, what I mean with minerals. Minerals, guys, are natural, non-living, solid crystals that make up rocks. Natural, they are found in nature, we don't make it. Non-living, they are not a living thing, solid crystals that make up rocks. The rocks are made of minerals, and those minerals that make up rocks are called what? We call it rock-forming minerals, okay? Examples of minerals, do you know that the salt in the food, it's a mineral? The fork you use to eat is made of minerals. And the ceramic plate that you put food on, it's also made of minerals. In the picture to the right here, you can see the same mineral but having different color. The pure quartz, it's clear, but different impurities can give it different colors. What is the relationship between minerals and rock? That's right, I just told you, rocks made of minerals. How are the two examples of quartz described above alike and how they are different? Hey guys, do you know sand made of quartz and the sand in Saudi Arabia, the same like the sand in California, the same as the sand in Egypt. It's all having the same chemical makeup. It's all having the same chemical makeup. If it have different colors, it means it have different impurities, but the same mineral have the same chemical composition. So the answer here, the similarities they have in the same chemical makeup and the differences maybe they found in different locations. The sand on the beach on the Red Sea is the same as beach on Cuba, for example, or Maldives. Same. Properties of minerals. Scientists identify minerals by testing their properties. We have 6 main properties we are going to talk about today. First one, color, luster, hardness, streak, cleavage, and crystal shape. Maybe guys, you will find the same mineral but having different colors, exactly like the previous examples that we talked about. Same minerals can be found in different colors, and even you can find different minerals but having the same colors. So that's why using the color only is not enough to identify a mineral. Luster is what? It is the second property we will talk about. It's the way the surface of a mineral reflects light. You think a piece of a chalk, like a piece, like a fork, or like a piece of metal, each one having different way to reflecting light. A glassy luster is shine like glass. Metallic luster looks like polished metal, and soft shine can be described as waxy, silky, or pearly luster. To understand it in a better way, take a look for these examples. Look at this one, it's called galena. Galena, it has a metallic luster. It reflects light like a metal. Satan's part gypsum, it has a silky luster. Calcite has a pearly luster, and it can be colorless, white, or other pale colors. A piece of glass, a piece of metal, and a piece of rock, they have in different ways to reflect light. That's simply a good way to reflect light, to describe luster. Hardness. Hardness simply, it's how easily the surface of a mineral can be scratched. How easily the surface of a mineral can be scratched. Maybe it's easy to scratch a piece of talc, but it's not easy to scratch a piece of diamond or a piece of quartz. Talc, it is the softest mineral in Mohs scale. A scientist, his name is Mohs, he made something called Mohs scale for hardness. He arranged some minerals and give it a rank from 1 to 10. 1, it is the softest mineral, and number 10, it is the hardest one. A mineral can scratch any other minerals that have in a lower most ranking. The softest mineral we have here is talc, and gypsum, the third calcite, fourth fluorite, number 5 apatite, feldspar, quartz, topaz, corundum, and diamond. Diamond is the hardest mineral. Otherwise, the machine that they're using to dig in the ground to get oil, they're using a head of made of diamond because it's so hard. I told you that any mineral can scratch all the minerals before it. For example, calcite can scratch gypsum and can scratch talc. And apatite can scratch fluorite, calcite, gypsum, and talc. Any mineral can scratch those minerals that they are before it or they have in a less most ranking. Do you know? Your fingernail on Moses scale, it's from 1.5 to 2.5 Moses scale. That means your fingernail can scratch gypsum and talc. The blade of a knife, it has hardness about 6.5, so it can scratch feldspar till talc. And diamond can scratch all the minerals here. Streak. A streak is the powder, is the color of the powders that a minerals leave when it is scratched across a special plate. For example, if you get a piece of cinnabar, which has almost reddish or black color, if we scratch it across a special plate, the powder of this one to look red, it have a red streak. Pyrite or the fool's gold has a green black streak. You can see despite it has a golden color, but it's a streak, it's what? Green black streak. So if you have a few pieces and you don't know which one is the real gold, you can test it for streak. And the real gold will have a golden or yellow color, or a golden or yellow streak. And pyrite or the fool's gold will have a green black streak. That is the way you can figure out which one is a real gold and which one is fool's gold. Orpiment has a pale yellow streak. Shape and cleavage. Each mineral has its own specific crystals that are particular in shape. Crystals are classified by these shapes and angles that they form. For example, take a look for this one, fluorite. It has a cube-shaped crystals. It has a cube-shaped crystals. But on the other hand, corundum, it has a hexagon shape. Hexagon, guys, mean it has 6 sides. Most minerals will break in definite pattern. If we get a piece of mineral and we just break it with a hammer, it's break along a smooth and flat surface. So this mineral has cleavage. Cleavage is break along smooth and flat surfaces. Example, mica breaks into thin flakes that are flat and smooth. Magnetite crystals often form shapes called octahedrons. Octahedrons because it has 8 sides. And halite, which has a cleavage in 3 directions. By the way, halite or halide, it's in the minerals form. It is a mineral that form of table salt. And what I mean here with having 3 directions, it's like this here. These are 3 directions. This question number 6, why testing for cleavage will be the last thing you do? Because you will have to break the sample and that's destroyed to check or test its cleavage. Other minerals properties. Maybe some minerals we can test another things, test another properties for it. Just like some minerals we can test its smell, test its taste. Okay. Other minerals test it by chemicals, just like if you drop a vinegar on calcite, bubbling will occur. Some minerals they have a magnetic properties. They can be attracted by magnets, like magnetite and peroxide. Peroxide and magnetite can be attracted by magnets, and even magnetite itself can actually be a magnet. Use your senses, other senses, to identify minerals. Not all minerals feel the same when you touch, taste, or smell. The picture to the right here, it's for magnetite in the lodestone attracts objects that contains iron. How can minerals be classified? By the properties I told you: color, streak, cleavage, hardness, attracted by a magnet, using your senses by smell or taste or touch. Which property might you test by rubbing one mineral directly against another one? That's hardness. You remember when I told you that each mineral can scratch the minerals before it or having the list ranking on Mohs scale? Now guys, we got to the end of our lesson, how are minerals classified. Hope you all understand it. If you have any questions, just write it down in the comments below and see you in the next lesson. Goodbye everyone. Love you all.